Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Good day, grade 8 learners. Welcome to today's Natural Sciences lesson. My name is Patuchetsa Singo, and this lesson is proudly brought to you by the Gauteng Department of Education. In today's lesson, we're going to be learning under the knowledge area Energy and Change. The topic is series and parallel circuits, and the subtopic is parallel circuits and other output devices, which means we're going to be putting our main focus on parallel circuits and other output devices. Now let's look at today's lesson objectives. So these are the goals that we aim to achieve by the end of today's lesson. So at the end of today's lesson, you should be able to explain how components are arranged in parallel circuits, draw a parallel circuit, explain the effect of adding resistors to a parallel circuit, and describe output devices. All of this is sourced from your CAPS document on page 49. Now let's look at pre-knowledge. So this is what you've learned prior to today's lesson. So in the 5th and 6th grade, we were introduced to circuits and current electricity. So today we're just adding on from what we have learned from our pre-knowledge. Now let's look at today's baseline activity. So what I'm going to do is I'm going to read out the questions to you and then give you time to answer the questions, and then afterwards, we will do the corrections together. So question number 1 reads, define a series circuit. Define a series circuit. And then question 2 reads, what is the measuring device shown in the circuit below? So you look at that circuit and then you tell us what is the measuring device shown. And then the third question is this a parallel or series circuit? Explain your answer for 2 marks. So I'm going to give you 5 minutes to answer these questions. Then after 5 minutes, we will do the corrections together. Don't forget to send in your solutions to our WhatsApp number, which is 079-578-2908. Take note, when you're sending in your answers, please tell us the name of your school so that we can acknowledge you. Thank you. See you after 5 minutes. Welcome back, grade 8 learners. I hope you had a lot of time to answer all of the questions. So now let's look at the corrections together. So define a series circuit. A series circuit is one in which there is only one pathway for the electric current to flow. The components are arranged one after another in a single pathway. So if you wrote that, give yourself a mark. So now let's look at the second question. So the second question was in reference to the diagram. The second question read, what is the measuring device shown in the circuit below? So let's look at all the components that are there and then identify the measuring device. We have a cell, so this can't be a measuring device. We have a switch, this cannot be a measuring device. We have two light bulbs. No, these are not measuring devices. So we're left with the big A. What is the big A? The big A is an ammeter. The big A is an ammeter. Now let's look at the third question. The third question read, is this a parallel or series circuit? Explain your answer. So we're referring to this diagram. Is it a parallel circuit? Is it a series circuit? So you need to tell us what it is. So it is a series circuit. It is a series circuit. Why? Because the components are arranged one after another in a single pathway. If you look at, so remember this is the positive end, this is the negative end. So this is the one pathway, bulb number 1, same pathway, bulb number 2, same pathway, bulb number 3. So it is one pathway and all of the components are arranged in that single pathway. Right, let's look at terminology. So these are the important terms of the day, the terms that will help us better understand the concepts that are being taught or being learned in today's lesson. So term number 1, parallel circuit, which is actually part of today's topic. A parallel circuit is a circuit in which the current divides or branches into an alternative path. And then a resistor is a component that blocks or opposes the flow of electricity. And then load. Load is any device in a circuit that uses the energy that the current delivers. Let's look at our second batch of terms. The second batch of terms, we're starting off with ampere. Ampere is the standard unit for measuring electric current, and then an ammeter. Remember the measuring device that we had in our question 3 of our baseline assessment. An ammeter is a device that measures the strength of an electric current. And then resistance. Resistance is opposition to movement of charge in a conductor. So if charge is moving in that direction, resistance is going to move in an opposite direction to oppose the flow of current in a conductor. So now let's learn about parallel circuits. Parallel circuit. So a parallel circuit provides two or more pathways for the current passing through it. It provides two or more pathways. So the components in a parallel circuit are connected in parallel. So do you remember what parallel means? I'm sure you've met this term or you've come across this term in your mathematics. So parallel lines are lines that are next to each other. They're all moving in one direction, or then these lines, the lines that will never meet, they don't converge. Lines that will never meet are your parallel lines. So that is parallel lines. Now, so in a parallel circuit, now that we know what parallel means or what parallel lines are, so in a parallel circuit, the current is divided. The current is divided between the components in the circuit. So therefore, current increases as more resistors are added in parallel. And if one doesn't work, then the others will continue to work. That is why at home, you are able to switch on the lights in the kitchen and still keep the lights in the bedrooms and in the sitting room off. Even if switching on lights in one room and switching on lights in one room Or if all the lights in the house are on, but then you decide to switch off the lights in the kitchen. Switching off the lights in the kitchen is not going to affect the lights in the bedrooms and in the living room. So that is how parallel circuits work. If one doesn't work, or if one is switched off, the others will continue to work. Even if all the other mains, plugs, and switches around the house are off, it doesn't affect the one that is continuously on in the kitchen, the one where the refrigerator is plugged in, or the one where the air conditioner is plugged in. Why is it so? This is because a parallel circuit offers an alternative route for the current to flow through. It offers an alternative route for the current to flow through. So we are saying that a parallel circuit offers two or more pathways for the current flowing through it. So the components, they are all connected in parallel, and the current is divided between the components in the circuit. So it increases. Now let's look at this diagram that I have with me here. Let's look at this diagram that I have with me here with all the knowledge that we have now about parallel circuits and what parallel means, lines that will never meet. So here is an example of a parallel circuit. Let's identify the components first. So we've got, this is our cell, that is our cell, which is our power source. Our cell is our power source, and then we've got bulb number 1, bulb number 2, and bulb number 3. So when they are all connected, they are all shining, they are all illuminating, they are glowing, they are bright. But removing bulb number 2 does not affect bulb number 1 and bulb number 3. Remember when we were learning about series circuits last week, when we were learning with Mr. Madlala. Now, once you remove one component in a series circuit, the whole circuit is affected. It is now broken. Now, but in a parallel circuit, removing bulb number 2 does not affect bulb number 1 and bulb number 3. Does not affect bulb number 1 and bulb number 3. Okay, now let's continue with our parallel circuits. So, did you notice that each bulb has its own connection? This means that each bulb has its own supply of current. That is one important thing to know. Each bulb has its own supply of current. And this means having its own supply of current means that it does not have to share the current with other light bulbs. That's why when you disconnect other light bulbs, it will remain on. So the current flows from the negative end of the cell, then it divides so that some of the current flows through one light bulb and some through the other light bulb. So now let's look at this diagram and try to visualize what I've just said about not sharing the supply of current. So we have our cell there. Our cell, remember, is our power source. It is supplying us with current, and then we have our conducting wires. So let's think of these dots, these orange dots as our charges. Our charges are moving, our current is being supplied by the power source above my head here, by the power source. So now, as the current is moving, it's moving from the source. Once it gets to this point, do you see that the current divides? Some flows in this direction, the other charges flow in that direction. So they are divided. So bulb number 1 and bulb number 2, they are not sharing current. Each to his own, each is receiving its own. Okay, so when the current divides, it does rejoin and flow back to the cell. So if the bulbs say they are equal in resistance, let's say the bulbs are equal in resistance, the current will split evenly, half-half, 50-50. The currents will split evenly in half, and half of the current will flow through each of the bulbs. However, if the bulbs have different resistance to each other, let's say one is lower and one is higher, then more current will flow through the branch that has less resistance. I'm sure we have defined resistance over and over again. We said resistance opposes the flow of current. It opposes the flow of current. So obviously, when current is flowing, it's going to rather go to the path that has least resistance. Now, let's look at this diagram here and try and explain the concepts even more. So this is our parallel circuit. We've got, once again, this is our cell, our power source, bulb number 1, bulb number 2. So now, if these bulbs have equal resistance, which means the current that is coming from the cell, our cell here, the current that is coming from the cell is going to be split half-half, 50-50. If the bulbs have different resistance, let's say bulb number 1 has more resistance than bulb number 2, just look at, so bulb number 1 is receiving the blue charges, let's call them the blue charges, then bulb number 2 is receiving the red charges. So if bulb number 1, this one, has more resistance, it's going to, it has the least resistance, the resistance that is smaller, it's going to receive more current. So more current is going to flow to where there is least opposition, the lesser opposition in comparison to bulb number 2, Okay, so this means that the current will always or will prefer the easier path by offering alternative paths for the current to flow through, A parallel circuit effectively lowers the overall resistance of a circuit, and charges move faster through the circuit. So charges move faster through the circuit. Remember when you were learning about series circuit, now they are all connected in one pathway. There is no alternative path. So the charges are, we will experience resistance at bulb number 1, slow them down. Experience resistance at bulb number 2, further slow them down, and it will further slow them down, and experience some more resistance at bulb number 3, and which means they will receive 3 times the resistance, and now they will be slower and slower. Now, because a parallel circuit offers alternative pathway, which means that the charges have an easier way of moving and reaching the bulbs. So a parallel circuit effectively lowers the overall resistance of a circuit, and charges move faster through the circuit. So a drop in overall resistance can lead to an increase in the current. So if there is a drop in resistance, there is no resistance that is opposing the flow of current, there's going to be an increase in a current. So the more branches there are in a parallel circuit, the greater the current that flows through it. So you can imagine that at home, all the houses, all the circuits at home, they are arranged in parallel. So that when you switch off the lights in your bedroom, it doesn't affect the lights in the other rooms of the house. They still remain on. When you switch off the switch, or is it a plug or a mains, in one room, it does not affect the electric flow or the electric charges in the other rooms. It doesn't affect. So now let's look at this diagram here. What we are saying is, now these are 2 pathways. There's pathway number 1 represented by switch 1. Pathway number 1 represented by switch 1. And then there's pathway number 2 represented by switch 2. So here I want us to focus on the pathways. So which means, let's start by following the pathways. So this is pathway number 1. pathway number 1 is going in this direction. So that is pathway number 1. And then pathway number 2, from there to there. So we have 2 pathways. So when switch 1 and 2 are off, the bulb is off. However, when switch 1 is on, the bulb is still on because current is moving through pathway number 1. When switch 1 is off, switch 2 and switch 2 is on, the bulb will still switch on because the current is going to move through pathway number 2, the one that leads to switch 2. So that is the whole concept here, that alternative, in a parallel circuit, we have alternative pathways for electric charges to move or flow. For electric charges to move or flow. Now, let's look at the advantages of a parallel circuit. The advantages of a parallel circuit. Advantage number 1. Advantage number 1. If one light in the parallel part of the circuit goes out, the rest will continue to work. So that is a very good advantage. The rest will continue to work even if one has gone out or has switched off. And a second advantage is that it is easy to add resistors to the circuit. It is easy to add resistors to the circuit. Now, let's look at this parallel circuit. Let's look at this parallel circuit. So we've got bulb 1 and we've got bulb 2. So you see, removing bulb 1 didn't affect bulb number 2. So you see, you've closed the circuit, bulb 1 switches on, bulb 2 switches on. If you remove this one, bulb 2 still remains on. So if one goes off or one is removed, it does not affect the other components. It does not affect the other components because current will still find a pathway. Now, let's go back to this diagram and focus on the movement. So the red line is indicating the way in which current is flowing. Follow that red line. Bulb number 1 is on, bulb number 2 is on, and then the charges go back. Now, removing that one, you see, it doesn't affect bulb number 2. So current will always find an alternative pathway in a parallel circuit because parallel circuits offer alternative pathways. Now, let's look at the disadvantages. I'm sure I've already shown you the bursting bulb. Let's look at the disadvantages. Everything is an advantage and a disadvantage. One disadvantage is it is easy to overload a parallel circuit since there are more parts to follow. Remember, we have one power source in a parallel circuit. So it is easy to overload a parallel circuit because you continue switching, connecting, or creating other pathways. So it's easy to overload it. So the current flows faster through the circuit and the resistors tend to heat up more rapidly because the current is flowing very, very fast. So we have a safety issue there. Resistors are more likely to heat up in a parallel circuit, and this can result in an electrical fire. Let's look at that bulb bursting there. I'm sure it was overloaded or it was in a parallel circuit that was overloaded. So now let's investigate a parallel circuit. Now, so our aim is to investigate the effect of resistors in parallel. What materials are we going to use? We're going to need cells or batteries. We're going to need clips. We're going to need 6 conducting wires. We're also going to need circuit boards. We're going to need 3 torch bulbs. And this is our method. Step number 1. Connect a circuit with one light bulb and make a note about the brightness of the bulb. Make a note about the brightness of the bulb. And then step number 2, connect another light in parallel to create the parallel connection. So I'm going to give you 1 minute to copy down the A materials and method, and then we will continue from there. All right, now let's see the rest of the steps. Number 4, notice the brightness of the bulb and record your observations. And then number 5, add a third light in parallel. Another 1 minute to copy down these last 2 instructions. Then after 1 minute, I'm going to come back and then we will proceed. Now that we've copied down all of the steps, including the materials and the aim of today's investigation, we are going to go to our lab. Then in our lab, we'll do the actual investigation. So I'm going to take a 5-minute break in order to go to the lab and set up for our investigation. See you after 5 minutes. Welcome back, grade 8. I'm sure you are now ready for the investigation. So we said we need conducting wires. So these are conducting wires. We said we need 6 of them. So we've got 1, 2, 3, 4, 5, 6. 6 conducting wires. We've got our power source here. This is our power source. Our power source is the cells. And then we've got 3 bulbs. Bulb number 1, bulb number 2, and bulb number 3. So we're going to connect our series circuit our parallel circuit rather, one by one. So we'll start off with our power source. We're going to connect the batteries. There's our battery. Remember, 1 is a cell and more than 1, 2 or more is a battery. So we'll start off with bulb number 1. I'm going to connect bulb number 1. There we go. Then we take conducting wire number 1. Let's take conducting wire number 1. Take the shortest one. Conducting wire number 1 with the clips and connect our bulbs. Connect our bulb. Then we take second clip, connect bulb number 1. There we go. Note the brightness. Note the brightness. Write down your observation. Write down your observation. Then we're going to connect bulb number 2. There we go. Let's place it on the circuit board. Our second conducting wire connected to the power source. There we go. Connection to bulb number 2 is connected. Now the last one, bulb number 3. The last 2 conducting wires, power source. And let's see if it's going to switch on. Now, take note of the brightness. They're shining very brightly. If you remember from our last week's activity, the brightness was decreasing from bulb 2 and bulb 3 could barely shine. Bulb 3 was barely shining. But look at this. Remember I said in a parallel circuit, removing one doesn't affect the other. So I'm going to disconnect bulb number 3. Bulb number 2 and bulb number 1 are still shining. They are not affected by me removing bulb number 3. If I remove bulb number 2, bulb number 1 is still shining. It's not affected by me removing bulb number 2 and bulb number 3. If I connect bulb number 3, you see bulb number 2 is still off. Bulb number 2 is still off because it is not affected by bulb number 1 and 2. Current is still flowing, but it's finding alternative pathway. So just because there's a disconnection here, that's just because this is open, does not affect the other 2 because we have offered different pathways to allow these 2 to still be on. Let me connect it again so that you see our parallel circuit again. All right, so now I'm going to give you 2 minutes to write down your observations. And then after 2 minutes, we will write our observations and then conclude our investigation together. 2 minutes, let's write down our observations. Welcome back. Now let's see the results and observations. Let's see results and observations. Now, so observation number 1. All the bulbs shine brightly when they were all connected to the power source. None were going dim or going off. All of them were equally shining brightly. Observation 2. Disconnecting one bulb did not affect the rest. Do you remember when we disconnected bulb number 3? It did not affect bulb number 2 and bulb number 1. Also, when we disconnected bulb number 2, it did not affect bulb number 3 and bulb number 1. The third observation is disconnecting 2 bulbs does not affect the third bulb. It does not affect the third bulb. So those are our results and observations. So now I'm going to give you 2 more minutes to come up with a conclusion for today's investigation. Let's come up with a conclusion. Welcome back. Let's conclude. So our conclusion, the one that we've drawn from our investigation, is that the parallel circuit has branches that divide the current so that just a part of it passes through each branch. So no matter how many components are connected, there are never more than 2 sets of electrically common points. So there are numerous current flow pathways. So now we have come to our class activity. Question number 1. State whether the following statements are true or false. Statement A, the first statement: a series circuit provides 2 or more pathways for the current passing through it. Statement B, copper wire is an example of an excellent insulator. So you should state whether those 2 are true or false. Question 2. Consider the following circuit diagram to answer question 2A and question 2B. So you look at that diagram and use it to answer the questions. A. Redraw the circuit diagram so that the bulbs will shine brighter. 2 marks. And suppose you are given an extra light bulb to connect to the circuit. Draw a circuit diagram to show how you will connect the extra bulb if you want all the lights to shine brighter. I'm going to give you 5 minutes to complete this activity. Then after 5 minutes, we'll do the corrections together. Don't forget to send in your answers to our WhatsApp number 079 578 2908. I'll be waiting for those answers. See you after 5. Welcome back. So now let's do our corrections. So we're going to start off with question number 1. We had 2 statements. You had to tell us if they were true or false. So statement number 1 read as follows. A series circuit provides 2 or more pathways for the current passing through it. Is that true or is that false? Now we've learned about series circuits and we've learned about parallel circuits. So this statement is definitely false. A series circuit only offers one pathway, whereas a parallel circuit offers 2 or more pathways. Now, copper wire is an example of an excellent insulator. That is a false statement. Copper is actually an excellent conductor. It is an excellent conductor. Now, let's look at number 2, consider the following circuit diagram. You had to redraw it. You had to redraw it so that the bulbs will shine brighter. How do we do that? You simply draw a parallel circuit. Simply draw a parallel circuit. We have our bulb 1, bulb 2, and our power source. Simply draw a parallel circuit. And then, there we go for our part B. You are given an extra light bulb. So you have 2 already. So now if we get an extra 1, you've got 3. So you give it an extra light bulb to connect to this circuit. So draw a circuit diagram to show how you connect an extra bulb. If you want all of that to shine brighter, this option again is parallel circuit. Number 1, number 2, and number 3, and then our power source. Always remember your power source. So those are our 3. Those are our 3. Now let's look at other output devices, which was our 4th objective, which was our 4th learning objective, other output devices. So devices that can use electricity to function are called output devices. Examples of output devices are LED lights, heater, and a fan. So those are our output devices. We've got LED lights, there they are. We've got a heater, and we've got a alarm bell. Now, LED lights, what are those? We also call them emitting diodes. What are the advantages of LED lights? LED lights don't have a filament. And LED lights don't wear out. So which means they actually last a very long time and they don't get hot. And they also are a great way to save energy. So some screens use LED lights. So there's plenty, tiny little LED light on that screen, especially that big screen that you're going to see maybe at the taxi rank, that big screen, it uses LED lights. It's made up of LED lights, that screen that you see at the taxi rank, that big screen where they advertise on. So there are examples of LED lights. And then, now a heater is another example of an output device that uses electricity. A heater has a resistant wire in a heater. So that resistance wire, now, because of that resistance, because we're having so much electronic charges coming through and facing resistance, some of the energy is lost as heat. So in a heater, it gets hot when the electric current flows through it. So you see that's why those bars are red. And when you sit in front of the heater, you get warm. Then the other output device is an alarm bell. I'm sure you've heard the alarm bell ring or your school bell ringing to tell you that period 1 has ended. We're now moving on to period 2. So an alarm bell produces sound as output. So it converts electrical energy to sound energy. It is an electrical device. So that's what an alarm bell looks like. They come in different forms. I happen to like this big red round one, but they do come in different forms. If you get time, just walk around the school block, mainly the admin block. It's where you'll find the school alarm bell. And now, electric motors. These ones are also output devices. So an electric motor, what it does is it converts electrical energy into rotational movement. So you find them mostly in fans as well. Remember, a fan is rotating to move the air fast and to make the room cooler. So it is similar to a generator, but then it moves in reverse. So there is my electric motor. There is my electric motor converting electrical energy to rotational energy. Now, let's wrap up our lesson. What did we learn today? What did we learn today? A parallel circuit provides two or more pathways for the current passing through it, and then the overall current increases when two or more resistors are added in parallel. When two or more resistors are added in parallel, we also learned that devices that use electricity to function are called output devices. We saw a heater, we also saw an electric motor, we also saw a lamp bulb and LED lights. Right, so now let's look at the parallel circuit once again. So this is a parallel circuit. So now we have alternative pathways. We have alternative pathways in our parallel circuit. That's one thing you should remember. And removing one component from the parallel circuit doesn't affect the functioning of the other components. It does not affect the functioning of the other components. Okay, so here is our homework activity. I'm going to give you 1 minute to copy down our homework activity. Okay, 1 minute. All right. Thank you so much for sending in your answers, learners from Soshangube Tech SOS. Thank you for sending in your responses. Other learners, please note that you can still send your responses from previous activities. So in our next lesson, we're going to explain radiation of light and the spectrum of visible light. So that's what we're going to be doing for our next lesson. Until next time, please don't forget the 5 P's. Preparation prevents poor performance. Don't forget to join us next week, same time, same place. Until next time, bye-bye.